Good morning guys, I hope you are well. Welcome to another video. This is the first chemistry video. It's based on the discovery of the atom. As always, please follow on the social channels, Facebook, Instagram, and also subscribe to the YouTube channel. It really helps in terms of just helping me build my confidence and helping build the following of the channel. Now, like and subscribe. Now, in terms of understanding the development of the model of the atom, this is what we're going to look at today. So I've divided this into two videos, part 1 and part 2. The idea behind this is you can actually watch either video in whichever order you prefer. I think it's better to get a big picture first and then go into specifics, hence why I've done it part 1, part 2. But if you think understanding the specifics first and then going into the big picture is easier, then by all means watch part 2 first. So what we're going to cover in this particular video is how new scientific evidence changes the models we use and describing the stages of the development of the atom. Okay. The other video is going to cover why the new evidence led to changes and describing the key differences between the plum pudding model and the nuclear models of the atom. So, like I said, we'll talk about that in more detail in the second video. This video gives you an overall picture and hopefully take it from there. Now, the first thing I want you to do is right now, I want you to grab a piece of scrap paper, whatever you've got near you, and I want you to draw a cupcake. Bear with me. It makes sense. I want you to grab yourself a piece of paper and I want you to draw a cupcake. I'm going to draw it too on the screen, and I'm going to draw with brown because, you know, generally speaking, cupcakes are either yellow or brown depending on what filling you've got. So when I've drawn my cupcake, there you go, cupcake, boom, done, sorted. Now I'm going to give you some more information. Yeah, you can either cross out the one you've already got, or what you can do is just add to the one you've already got, whatever's easier for you, right? Now, I've told you that the cupcake has chocolate chips in it. How's your drawing going to change? Well, if I was to redraw my cupcake, I'm going to draw the same thing pretty much, because that bit hasn't changed, and also I can't draw, so that makes life easier. And I'm going to put some chocolate chips in it. Happy days. Now, more information. If I told you, right, okay, in addition to having chocolate chips, it has a lemon swirl on it, how would you change your diagram, right? And then in addition to having a lemon swirl on top, I said that it also has melt in the middle chocolate filling, right? Clearly, what you do is every time I've given you more information, you've taken what's already there and you've added to it. You wouldn't necessarily draw a completely different design of cupcake. You would pretty much draw the same thing. However, what you do is with the new information that you've got, you're gonna then start. Don't laugh. All right, that is filling chocolate, filling the middle. Bear with. All right. But what you've done is at every stage you've added information or added to your model of what a cupcake would look like, right? And that is key in understanding how the atom has developed over time. Every time new scientific information has been discovered, what we've done is we've taken what we already know about the atom and we've adapted the model slightly to add the extra information that's come in. So new experimental evidence may lead to a scientific model being changed or replaced, and this applies across the board. It's not just for the atom, it applies to everything that we look at in science. Before the discovery of the electron, atoms were thought to be tiny spheres that could not be divided. All right, so and Greeks had this first idea, and they started off with breaking things down into small pieces, and they thought once you get to the smallest bit, we're going to call them atomos or atoms. Yeah. Now, it was actually a series of people that found, discovered, and you know, did experimentation to work out and adapt and change the model that we currently look at. And it's these guys on the board right now. Yeah? And these are the guys that you need to know about for your exam. Now, what we're going to do is we're going to take a look and we're going to build up a timeline in this particular video of how each person contributed. Right? You ready? 3, 2, 1. Let's go. John Dalton. He was the first one. Now, John Dalton, and you need to remember the names as well, John Dalton came up with this idea that matter, once you broke it down, once you took a block or whatever it might be, once you've broken down an element into its fundamentals, it can't be broken down any further. And he visualized this as, spherical marbles, almost balls, that each different element would have its own type of atoms. So oxygen, whenever you broke down and had oxygen in its purest form, it would have oxygen atoms. You with me? So if we draw, let's keep it purple. If we draw Dalton's model of an atom, it was ultimately just a spherical ball. Yeah? And it was revolutionary at the time, but in terms of understanding the structure of the atom, that was pretty much it. That's as far as we got. And it wasn't until 1897 when J.J. Thomson discovered something else. Now, what did J.J. Thomson discover? I know I've got people behind the screen shouting, he discovered an electron. Well, J.J. Thomson's discovery of electrons meant that we changed the model of the atom from what it looks like to incorporate those electrons. So what J.J. Thomson did was he took the spherical ball and he said that electrons were negative, so he added them in to his diagram. Now that kind of looks like, if you don't know what plum pudding is, Google it, but it also looks like a cookie. However, electrons are negative, and J.J. Thomson had discovered that these charges were negative. And if they're negative, then something else needs to be positive. And so actually what J.J. Thomson said was that overall, the rest of the atom is positive, and then it's got the negative electrons in it, which means overall the atom is neutral. Yeah? And that was only a short-lived idea, because in 1911, Ernest Rutherford did experiments to actually prove that the plum pudding model was correct. But in his experiments, he discovered something. This was called the alpha scattering experiment, or the gold foil experiment, whatever your teacher has told you, go with that. Yeah. But basically, from Adam Rutherford's experiment, and I've gone into detail in the second video, they discovered that actually most of the mass of an atom is concentrated inside a very, very small space. So this size of the atom is not actually true. When I say a size, I mean in terms of where the mass is, it's not actually true. There's a very dense positive nucleus, and then all the electrons are actually just floating around the outside. Yeah, so I've got one electron there. I've just represented them with crosses because they're easier to see. And you've got a dense nucleus which is positively charged, and the electrons are around the outside, and most of an atom is empty space. Now notice very clearly what I've done here. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 electrons on the outer shell of this particular atom. Now I know some people are like, whoa, hey sir, you can only have 8. That was the point. In Rutherford's model, he didn't come up with the energy levels. He just came up with the idea that the nucleus was positive, it was dense, and it was in the middle of the atom, and the electrons were around the outside. It wasn't until 1913, a couple of years later, when Niels Bohr was doing experiments with hydrogen, and he discovered that electrons move around at specific energy levels, right? Specific shells. So again, the model of the atom was changed. So how does the model of the atom change? Well, I've still got to maintain my positive dense nucleus in the middle. Yeah? And then I've got energy shells which hold electrons around the outside. Now in this one we've done 9 electrons, so we're going to do 9 again. 1, 2, 3, 4, 5, 6, 7. Yeah? Where you draw the electrons isn't particularly important. However, notice that we've still got one thing in the middle. Yeah, we've only got one positive dense mass, and it wasn't until a little later when they worked out that actually protons exist, because that positive mass is made up of smaller particles, which have a positive charge, and they always occur in the same amount of charge, and hence why, therefore, it must be. They must be called protons. Now, in terms of breaking that idea down, if you thought of, if you went to a shop and the shopkeeper always gave you, £1, 10, 90p, 80p, 50p, what coin do you think the shopkeeper most likely has a lot of? Now, hopefully what you can work out is he's probably got lots of 10p coins in his till. Yeah, and that's kind of what they did, is they looked at the overall charge. They said, well, the charges always occur in this multiple, and therefore it must be something that's making up that multiple. So the easiest way to think about it is, if I've got £1.10 change that the shopkeeper needs to give me, then actually he's probably giving me 11 10p coins. Yeah, again, with 80p, 8 10p coins, you get the idea. So that's kind of what they did to discover the protons. However, it wasn't until slightly later, until 1932, when James Chadwick discovered the neutron, and actually that is the model that currently you guys learn at GCSE. So this model here, where you've got protons in the nucleus and neutrons in the nucleus, as well as electrons on energy levels on shells round the outside, and the number of electrons that can fit on each shell, we'll look at it. If you go back to structure of the atom video, you can understand that. Now, hopefully that makes sense. And so the reason why I wanted to provide this picture, or this kind of overview, rather than talk about specifics of each individual person, is it allows you to see how the atom was built up. In terms of the best way to learn this, there's a couple of ways that you can do this. Take a screenshot now. Obviously, try and cut my face out, but take a screenshot. And once you've taken a screenshot, what you can do is draw the model of the atom underneath it. Yeah, so for each person, draw how the atom developed. So you've got Dalton with a sphere, you've got J.J. Thomson with a positive sphere with electrons in it, etc, etc, etc. The other route that you could take is, you could take another screenshot now, and then work out exactly, or rather write down who was the person that discovered each individual thing, and what was the evidence that they used to develop their particular model of the atom. Alright, boys and girls, agents, hopefully that's been really useful. If it has, that's fantastic. Like and subscribe as always, follow on the socials. Thank you very much, look after yourselves, be safe.